All right, so we're going to go over the factored form quiz questions, and we're going to give you some hints to help you out with these. Remember that you're not going to see all of these questions, and that you're only going to get about 10 of them, and each time you take the quiz, you might get a different set of 10. So as you're going through this video, grab a sheet of paper and take down some notes to help you answer the questions, okay? So this first one here says, which point is an x-intercept of the quadratic function f of x equals x plus 6 times x minus 3? And the best way to do this one is to go to your calculator. And so remember, to get to your calculator, you go to Google Classroom and then you click on classwork. And over here, it says calculator. It's just this Desmos graphing calculator. Okay. And it says x plus 6, x minus 3. So you're just going to type that in right here. X plus 6, x minus 3. And it will graph it for you. And if you click on the points, it'll actually tell you what the points are. Okay. And so what you're trying to do here is you're trying to find the x-intercept. So you're looking, when this is graphed, that's your x-axis. So you're trying to find which one is the x-intercept, and it's one of these 2 points that will be listed. Okay, what is the y-intercept of the quadratic function? And f of x equals x minus 8 and x times x plus 3. And this time you're going to basically do the same thing. You're going to graph it in Desmos, but you're going to look for the y-intercept. So if you graph it here, this is your x, this is your y. And so if I have a quadratic function, what I'm looking for is this y-intercept. Where does it cross the y-axis? Okay. This question, same thing. The y-intercept. And remember that a y-intercept is 0 and then your y value. Okay, so that should eliminate a couple of choices as well. But graph it in Desmos and see where does it cross the y-axis. Okay, which function has a vertex at the origin? The origin is your 0, 0. So that means if let's start by drawing the x and y axis. If I draw my x and my y, and I were to graph an equation, the vertex, the middle point, would be at 0, 0. Okay, so the vertex is your middle, and it's your highest or lowest point. Okay, and whatever that middle point is, the highest or lowest point has to be at 0, 0 for this to be your answer. And again, just go to Desmos and type this in. And when we look at the calculator online, this little x will clear out what's there. And you can type the f parentheses x, you don't have to, equals x minus 4 squared. Okay, how you get that squared key is you come down to this little keypad and you click the A squared button if you don't know how to use the keyboard, okay, and that will give you your x squared, and you're looking for something that crosses right here at 0, 0. All right. What is the midpoint of the x-intercepts of f of x equals x minus 2 and x minus 4? And so basically when you graph this one, here's your x, here's your y. When you graph it, you have 2 x-intercepts. You have one, wherever they are, here and here, and you're looking for the point that's in the middle, okay? What's in the middle of your 2 x-intercepts? So if this was -1 and this was 5, the middle would be 3. Maybe it's 2. Okay, so whatever's in the middle of them, because there'd be 3 spaces in between. Okay? All right, which is the graph of f of x equals x minus 1 times x plus 4? Again, this is just graph it on Desmos and see which one matches, and look for the specific points. Look and see which, like here's your vertex, and it's in a different quadrant every time. So look and see where that is, or look and see where your x-intercepts are, okay? It's graph and match. Same thing on this question, which is the graph of f of x equals negative x plus 3 times x plus 1. Just put it on Desmos and graph it. This one says the graph of the function f of x equals x plus 2 times x plus 6 is shown below. Which statement about the function is true? And then this one's a little bit confusing because we never really talked about a function being positive or negative, but your function is positive, so I'll do some green for positive. So it's positive here and positive here because it's on the positive y. And your function is negative from here to here. From negative 6 to negative 2, your function is negative. So it kind of just gave you the answer, right? So if you're looking at negative, it's negative at negative 6 to negative 2, okay? So this side is negative. Up here, these are the positives. This is the positive side. All right. Which statement about this function is true? It's similar to the one we just talked about. So remember, your function is positive if it's on the first or second quadrant where your y is positive, and then your function is negative down here. Okay, so here we're at negative 3. And here we're at positive 1, so it's positive on the top, negative below that. Okay, I think I'm going to come back to this one. It says the function is positive for all real values of x, where x is less than negative 1. So if x is less than negative 1, well, my function is also positive and negative. The function is negative if x is less than negative 3 and greater than 1. Sounds like that's your answer, okay? The function is positive if x is greater than 0. So if x is greater than 0, but we have a positive and a negative spot. And then the last one, the function is negative if x is less than negative 3 or x is greater than negative 1. Well, negative 1 is right here, and I still have a positive spot, okay? So it kind of just told you the answer to that one. All right, which statement about the function is true? The function is increasing or decreasing here. So this is a little bit different. This is not positive or negative. This is just where is your line increasing. So this part here, my line is going up, 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 up till I get to this point. This is increasing. Okay. And then from this point back down, okay, this is decreasing. And we're looking at our x value, so the turning point here is negative 4. So the function is increasing if x is less than negative 4. Is that true? The function is increasing if we're between negative 6 and negative 2. So that's from here to here. We're going up and back down. The function is decreasing if x is less than negative 6. But if I'm less than negative 6, my line is still increasing. And then the function is decreasing if x is less than negative 4. So here we're at -4, and if I'm less than that, my function is increasing. So I kind of told you the answer to that one as well. All right, this one though, try it. The function is increasing or decreasing. So again, we're talking about that point. And so if I look here, this line is going down. And it's going down until we get to an x value of about 1.5. So this part here is decreasing. And then this side of the graph is going back up. So this part is increasing. Okay. So the function is increasing if x is less than 0. Think about that. That's from here and over. The function is increasing if x is less than -1. That's from here and over. Does that really make sense? The function is decreasing between -1 and +4. Is it decreasing the whole time? And then the function is decreasing if x is less than 1.5. So think about which of those makes sense. All right, now we're going to talk about some domain and range. So what is true about the domain and range of the function? Well, what you can't see is that they forgot to put some arrows on here because it goes on forever. Okay, so your domain goes left forever and right forever. So that means your domain, if it goes on forever, your domain is all real numbers. Okay, and then let's talk about your range. Your range is your y values. So if I look at my y values, where do my y values start? Because they're not all real numbers. So my y values start right here at -4. And if they're going up, it's greater than. If they're going down, it's less than. Okay? So let's read through these. The domain is all real numbers. The range is all real numbers greater than or equal to -4. This one says the domain is all real numbers and greater than or equal to -4. So this is saying my domain has a stipulation of -4, so that doesn't make sense. This one here, the domain is all real numbers between -6 and -2, but we just said the domain is all real numbers. And then this one says the domain is all real numbers greater than or equal to -4, which is what that one said, so that doesn't make sense. Well, I just gave you the answer on that one too, okay? All right. What is the equation of the quadratic function with a vertex at 2, -25 and an x-intercept at 7, 0? Okay. Now, I will tell you that when you graph these in Desmos, you're going to get 2 that have this correct intercept. So you have to look for both things. And so you're going to graph it. And here's my y, here's my x. And so here's 1, 2, 3, 4, 5, 6, 7. And then 2, and we'll say down here is 2, -25. And what you're looking for is a graph that goes all the way down to that point and also comes back up and crosses right here at 7, 0. Okay, so use your calculator, graph all of those. And when you're looking at your calculator, you can kind of click on it and slide it. So if you needed to get down to 25, okay? So like a click and drag type of thing. All right, this one, part of the graph is shown which statement about the function is true. And this time it says that you have to pick 2 options. Okay, so remember the vertex is your highest or lowest point. Okay, basically it's your middle. And you can't see it on this graph. So what I would do is I would go to Desmos and I would graph it and figure out which vertex is correct. And then it says the graph is increasing only from -4 to 6. But we can see my graph is decreasing and increasing, so that's not going to make sense. And the graph is positive only on one interval where x is less than -4. So if I'm at -4, my graph is positive. So positive and negative are different things. Remember, positive is above the x-axis. So these are both positive. Okay. And then these are negative, which is confusing when we're talking about increasing and decreasing. So the green is positive and the red is negative. Okay. But if I want to talk about increasing or decreasing, this whole side is decreasing. And this whole side is increasing. Okay. All right, so is it positive at only one spot? Or is the graph negative between -4 and 6? So is my graph negative between those two numbers? Okay, so this is one of your answers. It's not just positive one time, so it's positive on 2 intervals, not 1. Now you need to graph it though and figure out what your vertex is. All right, what is the axis of symmetry of this function? So again, you should graph it on Desmos. And remember an axis of symmetry. So if this is my graph, an axis of symmetry cuts your graph down through the vertex. Okay, it's an x equal and whatever this vertex is. All right, which function has only one x-intercept at -6, 0? So basically you're graphing this and you're looking for -6, 1, 2, 3, 4, 5, 6. So this is -6, 0. And you want your graph to come down and touch that point and go back up. Okay, or it could be upside down. But down and back up. That's what you're looking for. So graph these answer choices on Desmos. Which function has 2 x-intercepts? One at 0, 0 and one at 4, 0. I'm not going to give you too much help here. You're looking for, you got to graph these and figure out, here's 0, 0, 1, 2, 3, 4. Here's 4, 0. And you got to figure out which one goes through those 2 points. The graph of the function is shown, which describes all of the values for where the graph is positive and decreasing. Okay, so we want our graph to be positive, which means it's going to be up here, right? It has to be this or this. And we want it to be decreasing. So decreasing means when your line is going down. So this part right here is what we are talking about. And it starts right here at -1 and it's getting smaller. All right, what is the range? Remember, range is your y values. So my y values look like they start right here. And are they going up and getting bigger, or are they going down and getting smaller? Okay. All right, that's the end of that.